Hello everyone, my name is Edward Lin, and today I want to talk about the neural network. To build a neural network with Python, if you have already know the basic concept of the neural network, you can uh, you can watch this video directly, and I will go the step by step to tell you how to build a neural network with Python. So uh, let's install a Python in your computer. I today the IDE the Python we use the IPython, and this is the website. You can find where the IPython is. Just one moment, and we can see. Okay, and if you can choose the Python 3.6 version, and I think I already downloaded uh, this Python. I already done it. Do it. You can in this website you can choose the the appropriate version for the Python for your writing. Basically we use the Python 3.6 version, and the Python 2.7 version is the old version, and it could all compatible uh, uh, with with uh, with our need. We basically in this video we use the Python 3.6, and okay, and you download it, and you just install it. It's very easy, I think. And then we can. I have already downloaded, and so I just open it. I just find out where is the Python is. Okay, I will find it. Okay, just one the meaning. I think they will be good immediately. Okay, what's the problem? Okay, we got it. And we open a new the notebook Python 3. And next I will I will we just enter these words. I think if this is this one we okay. I think let's let's due to the because you have two kind of okay, I think it works right now. Okay, the Python is worked, and I think I think all of you have some basic knowledge about the programming language, so I just ignore the most part of this, and then let's go directly to build how to write write a neural network. Okay, and First, as we all know, like the neural network should have okay. Before we go into the how to build a neural network, let's just see example about how the object-oriented program works, and we have this class, okay? We enter this class in IPython and paste in the pass. Okay, we have to do some indent. Oh no. The temperature pass. Okay. So we think we have already defined the. I assume that you know the basic knowledge about Python. So we just want to do so much details about how to write a Python here. You know how we do the intent because it's the way that the Python writes and it's a little different from the C++ and Java. And we have already defined a class dog and the initial of the class is the head name and the temperature. So this is the initial function. This is the status of the door and define, and this is the temperature of this, and this is the a master of the door, and this is the class. So and then we have to use this class. Okay, we just add a new to use this class, and maybe we have a door called Nancy, and we just this is a door. We just build a instance of this class. This is door called Nancy. This is the name, and the temperature is I think it's 2035. Okay, let's run this to see if it works properly. Oh, they have line 95 in the data and expect an internet block. Okay, I think this is way more because the indentation is caused it's a way that okay, and then we have Nancy. Oh, okay, we should and then we just so we build a status. Mm, we build we create an instance of which name the instance of door and the name okay, so the door's name is Nancy and the temperature is 37. I hope here you can know why this works. Temperature 40. You can write any number you want, and then we just we track the and then one. Okay, you can see the door temperature is 40 now. So you know how this IPython works. I hope you understand that. And how? Okay, let's go directly to write a neural network with Python. Firstly, I want to I assume that you have already know the basic concept of a neural network. So, in order to build a neural network, we need three very we need three functions: the initialization, the train function, and the query function. And I think we have to build this function step by step. Okay, so you have the frame, you have the structure of the whole class, the neural network class. So there's three functions here. So we don't bother to type it one by one, and then we create a new one, and when the meaning, okay, open a column, let's just save it and then class save, did you save, save file? Let's open a new Python 3 notebook to build a whole new neural network paste. This neural network, okay, and we should get some indent to mark how the okay. So this is the basically this is the three the skeleton of our neural network. And firstly, we have to initialize the neural network. So as a neural network, we all know that you should have input nodes, hidden nodes, and output nodes. And actually, it need some learning rate. If you get some, okay, so we just clip it into the direction. We don't bother to we don't bother to write this because I think there's because the format is also a proper, so we have to do some adjustment. And basically, we have to do some intention. Then anyway, learning rate. Okay, we just in the initial function, we uh just set up the whole parameter of the neural network. You know, as a neural network, you should have at least four parameters. And this is a neural network. Okay. Okay. So if we want to build a three-level neural network, each level have three nodes, and we have a learning rate 0.3. We can write this. Right? We can build a neural network like this. And for the moment, and we can build, because this is just for the class part, and we can build a neural network. I think it just worked. The input node is 3, the hidden node is 3, the learning rate is 0.3, and we have built a neural network. So this is the neural network. We just run this paper to make sure that it is it's type for some 914. 914 pass the integrated inspector and integrated block. Which one? I have no idea. 914. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I see. Indentation. Let's see. Need an indentation. I think it's not a problem. I think it's the oh shit! What's this? What happened here? Expected and intended block. Unexpected intent. Input low. Okay, the intention really drive me crazy, but that's fine. 14, we need an indentation. Let's just ignore it. Let's see what happened. Oh, okay. Okay, we just leave here and go on because this is not the important part. Oh, I got it. I got it. What? Because the intention is very important. Okay, sorry. I just not very familiar with this kind of. I think right now it works. Okay, and we also build a. Okay, we also build a neural network of 3 points of three for the deleting, and then what should we do next? And we all know that if we build a neural network, we have a, we have we have the way of the link. Way of the link. So this is the heart of the network, and so we have next we have to create a neural network with nodes and links. The most important part of neural is the link weight. Okay, and a metric of the weights for link between the input of the level, the this we define this a size of internal by this, and the other is the hidden because we have three levels: the input level, the hidden level, and the output level. So between these three levels, we have two metrics for the weight of links, and now we have to introduce a new method which is called NumPy. NumPy should be we have to import the NumPy first, and then we have to. I will show you how the NumPy works. Okay, we have to import it. Import NumPy, and then actually we can use it. This one. Let me try. Directly just use this one. Paste because we just copy the files directly from the PDF format. So the format is a little changed. So we have to do some adjustment. Just make sure that the IPython can recognize this, and that's what we run this. Oh no, why there's no? Okay, this is okay. We can just do it. Paste and okay. no n column, but which the no n column is okay. I think the three no three column. Okay, you can try anything you want. It just generate a matrix with random number, and we from the observing we can see that the matrix the number that is randomly, but it's just between 0 and 1. It seems like okay, so you know how it works. But this is we hope that we should get the range from between minus 0.5 to minus 0.1. So we just minus 0.5 to address the range of the number, the generate number. So we get a bunch of numbers that range from minus 0.5 to positive 0.5, and that's a cool thing. That's cool. So, okay, so you know how this works. So this is the link, the matrix, as it's still located in okay, there in those the link. This it is still should be included in the initial path. We should include it in the. Think about it. We need we need so we should include it in initial part, right? Yes, we should include this in the initial part because in no uh, paste it paste link. We have to link. Wait inside this. We have to build a link for the whole neural network. What the paste? I think I already copied and paste. Actor. Okay, so I think we have already built the 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 way the matrix of the neural network. Actually, we have should use the more the complex one. If you like, we can use this. But right now, let's we can use this one to build a neural network. I think it's more. You know the normal distribution. You know what's the inside of this. Let's just use the more complex one. I think it's more sophisticated for us to use this one. We just comment it and -1. Okay. So and then we build this the initial. We get in, we get network, but we don't know how use it, how can we use this network. So we have to query this network. We have to do the connection because so we use this, and because the hidden is the input times I input, we have to first we have because it's the network the single is just passed through from the input node through the hidden node and then to the output node. So we have to generate the input of the for the in hidden node hidden neighbor. So this is the formulas of that how we calculate the singles. So we have to find out this. So this should be in this should be in okay. This should be put. We should put it in the query function. Paste. Oh no. Paste. Hidden input equals this. We calculate this. We have to operate the whole neural network, and then think about it. When we pass the singles from the hidden level to the upper level, we have to do something to that because we don't want to respond to a noisy single. So we need to we need a activation function to get rid of the noise. So this is the formulas of this action. So in order to achieve this in order to achieve this active function, we have to import another libraries. Okay, this is the spicy import simply special. This is the special rule for this. Okay, we can just input here. I think that's okay. Okay, that's fine. Oh, okay. Oh, no. Because we have to use it in no, and we have to add no. Mm, that's Monastery. Okay, we can import these libraries before we use it in the class. Yes. So so you can see that we can very easily operate we do it in this um in in IPython. Okay. So we have to uh, build these active functions in a query. Okay, let's paste it. This is the active function. So this function, what does this function mean? This function a little weird, and this means that this is actually as an anonymous function. It's a logical function, anonymous function, and you will get familiar with this. Actually, we have this name to the active function. We assigned this anonymous function to activation function. And then we can calculate the single emerged from the hidden level. Hidden input. So in the query function, we have first we have get the input singles of the hidden level, and then we define the activation, and then we apply this activation function on the hindered input and to generate the hindered output. So you can see the whole process. Okay. But we don't know either input their input their input either opposite or we also have to do the same thing for the final input final output, and basically it's the same so we can just do this because no activation is there's no method activation. Before we use the activation, we have to define the activation, and then we so you get it. So you get what you mean. So we just generate the input output, the hidden input hidden output, final input hidden output, and I hope all this works well. And then we have okay we have to okay we have actually we have defined the activation function in the activation function in the initial value, because we can if we define here we can use it many times. Okay. We sometimes you have to think about where you put your function and lambda array. We have to first in the initial function in the initial the function we have to define all the things we need in the operation of the neural network. So we can use it in the other functions. This is kind of okay. Convert the input list to a 2D array. We have to actually because the input so the query for the query we get input input list, and we have to translate this input list to something like we know the 2D array. Yeah. That's what I array in the query. Uh, final output, and then we have a retained value for the query function retained. We have to retain. Before query, we have retained the answer, right? So this is why they call them retained. So if we retain, we don't pass. Pass is just for and for the no return value. We have for the query function we have a return value, the final output. So last part we have to test whether the query function we have to test is the query function works or not. So we have the neural network N, and we queried. We have the input list. There should be have an input list. Bullshit. Anything you want? Okay, let's try whether we would write the loans. Oh no. Query take 0 position argument but 2 were given. We have to run this first, right? And then this. Run this. And then we got this. Okay, we got it. And this is a rate. Hello. So far so good. There's output because it's a 3 input, 3 output. Queries we have a 3 input and then we have an output. Okay. So far so good. And then we have to train the neural network. How would to do the training? So we have to training. We need the label the. This is the most important part of the neural network. How do we do the training? Actually, for training, we need to the input list and the touch list because it is a supervised learning process. So we definitely have to give the neural network the answer. So we have input and the neural network generate the output, and then we just compare this output with the correct answer. If there's some difference between the output and the correct answer, we have to address the weight of the neural network and then improve the answer. So for the train function, we need an input list and a touch list. And first, we have to convert the input list to a 2D array. And then calculate this and calculate. This code is mostly like a query function. And it's very easy one. Just do. So we have to paste here. Okay, let's address this a little bit. So this is just like this is just like in the query function, right? And this is the input, and this is the target. Actually, I have a little. So how can we backward read the training? So in here we get the final output, and then we have to get the error, right? So we have to get the error. Error is the target minus actual. Target is this. Error is the target minus, so output error equals target minus final error. Output could be this is error. We get an error. We can find the output. We get an error, and then we get an error. We have to use this error to direct ourselves to address the matrix output error. Hidden error, output error, and from the output error we get the hidden error, right? This is output error. We have to backward. To do backward. To recombine the hidden node, hidden error. We can do the hidden error. And then we get a hidden error, and the hidden error, we have to how to use the hidden error. So we have to update the weight for the link between the hidden and the output. This is what we do. Okay, we address the. Okay, this is the update weight between the link for the link between the hidden and the output level, and then we also have to address the link the weight for the link between the input and the hidden. Update for the link between the input and the hidden. So I hope you all understand why this why the code like this way, the relationship between each vector between each numbers. Okay, I think I already got it. We have all these codes, and now we can do whatever we want, right? Let's run it. Okay, it's in there's no. Okay, the whole class is complete and works fine, and there's no bugs in the. Actually, there's no warning. Okay, this is the whole. So right now we have to use this neural network to do some useful things. and we get a training set and test set. The training set is 60,000 level exam. The test set is 1,000 test exam, but this is too much. Before we are sure that our neural network can work correctly, and we have to use a small set to test it because it can save us a lot of time and there are a lot of time. Yes, and before we use the complete set, so we just use the 10 records from the means the test and 100 from the means training set and says. And I have already you can open it. You can open it, but I have already downloaded in my website in my computer. You can next say the page is inside this. I just the same is in the neural network. In my Python 4.8, where is my save list? I have already saved this in my computer. Nice to set. Anyway, we can save it. Save page as the okay. Let's make the neural network. Okay, saved. Testing. Okay, it already exists. Okay, I just said that. I just set it here, but I don't know all files. Okay, I set it. You can set it is like this way. And this the first number is actually the label. The label. It means what this graphs means. Okay, let's see. Let's see example to write. Okay, data file opened. We can use a new one to see what's the how all this works. Delete. We just make it tidy and okay, we can see it. Open say I think I just how I just in order to make it clear, we just include the whole path. Neural network. Neural network means trade test the train. The train take. Oh, this is train for the train. Train 100 is refile. Okay. Make sure that you when you use these files, you have to close it. And then we need another line and a new one and press for the test. Okay, you can use the train. Then the data list 100. Okay, we can do some train. Okay. Let's do some. Let's run it. Okay, run it. 100. Oh, why? Laying data file object has no length. No length? That's ridiculous. Oh, data list. 100 data list. We just data list. Okay, sorry for the mistake. We just open the files and then we use the file list read all the files into the data list. And then we just find out we want to check out which the data list Let's see. 100. What's this? Whoa. 100? No. Whoa. Data list. 100. I make a mistake. We have to sometimes to make sure what. Oh. It is you should take care of this because this is beginning from the. Okay, this is 1. It's beginning from the 0. So if okay, sometimes it's very easy to make a mistake here. So we got this whole data file. Let's begin. What's the data list? 0. Okay, it's fine. So you see that IPython is very easy. First we and then there's we need to make a work make a there's a tips here. First we must forget to import the Python external library which help us to with the protein. Okay, numping. Import we have to also import this metapolice. Just make sure that there's import this before all the files. Okay, so even if since we have imported already in we can delete this and unless there won't be anything known. So you can see that the IPython is very easy to operate. And then we have to find out is it really 0 or something like that. We have to plot the whole image. Whole image, what does image mean? Okay. Test. All values if data 0 split with because it's split with this image array equals this. This is number function which that exclude 1. It means excludes 1 and reshape 28 array. And then we just use this to load. We just use the grade. If we don't use the grade, we can other things can hear. I don't know. It's great. No. Mental polynomial is not defined. Maybe we should run this before. We should run. Okay, we got it. It's fine. 99 it should be 0. Let's find another one. 1. Yeah. Okay. It seems that we got everything in place. Let's one. Okay, let's prepare the training data. We get everything okay. We have to because the node input is there's zeros, which this kind of input is we have to schedule the input of the data because if you know the neural network if there's a zero input there's trouble. It will cause some trouble. So we have scale the input. What's this? O values 1 equals 1 minus over plus times that only plus green signal you discount for that range is this. Huge. We've got trouble. O values. What O value? O value. Okay, this is the O value right now. The O value is 99. Okay, we can run this. Open like that. Okay. So we can find out that this the value is between 0.0 and 2. Okay, we got the correct answer here. We have scaled the input. Seems everything is fine. So we have an output because we got a number from 0 to 9. We have 10 numbers, so we need 10 nodes to. I think we can use another kind of representation to represent the number from 0 to 9. But I would like to use this 9 nodes. It's very easy and with the touch mixer. So we just copy paste on paste. On no touch is 0. And TR 0 plus equals 9. That's one is what happened. Nothing. Bring the touch. I don't know what will happen here. Bring the touch. Okay, the touch is 2. It's 1. It's because it's the okay. This is the touch. This is only 1. Oh, well, 0 is 1. Why he is whoa, let's it's 1. That's weird. Oh, I didn't do no. 99. What? 99 is 1. Okay. So we get a whole function, the whole program in place. I think there's not so much difference between these. Um, how already defined here. Self equals this, nothing it pass the transport square root. Okay, then we got the layered. We create a neural network. Create a neural network and know the data, training data, and train neural network go through all the records. Read. Okay, so in order to make it more unique, we just okay, we just delete all these things. Okay, this is the neural network we built. So we need to create a neural network that really works. We just copy this data. I hope it can work there. Paste it. Okay. This should be here. We have to neural network dataset. This is from n to the okay. We have to take intention here. We over equals record speed is equivalent over the neighbor which is touch equal to 0 and train equal to output. Now let's test the data. Update this one in the same way as before. We can put it in another book. Open a neural network data set. Okay, we've got everything in everything. So let's run the whole program. I hope there's no mistake. Okay, trade touch pass. Over is attached label for this recall. Over the equivalent label object have no attribute trained. Okay. Okay, I think we have run it. Neural network have no object trained. That's terrible. Neural network. Oh, neural network trained by for the values will input the get a target trained. Okay, I think I will train here. No, we have already defined a trained path. I see it. What? What happened here? Training data list. We can't find a train. Is there something wrong? For the course in training data list and the neural network. They are very nice neural network. Train a neural network. Go through all the course in general. Let's see what will happen here. Run again. Mode 0. You have to. Why? That's terrible. No attribute. Train. That's insane. Why there's no attribute train? Let's work this through. Mm. What's this? Definitely. I think it's okay, it's wrong here. Let me see what's wrong. Train to the node train. Ask input output. Hit enter. Hit output. Find output. Output enter. Hit enter. Output. Ask. Query trainer. Input touch. Hit output. Hit output. 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 don't think there's something wrong here. Get a wheel. Yes, nothing wrong. Neural network. Neural Neural network minister. If open training every night for early training list of values recorded record 301 equal record with a record Okay, I got it. I think I make a mistake here. For training data list, or value to the list, that's why. Here, what's the mistake? Comma. Import numpy. Import neural network class neural network. Paste. Numpy neural network. Should I pass? Here. What's this? What's wrong? Training convert etage. Import pass. Let's correctly direct this to the I don't see works. Paste. Final output interval output label self evaluate and close. Okay. Interval. Okay, I think there's some mistake in the original file. So we pass this. Okay. You got it. Go through all these values, input, output, testing. And then we just want to test it. Next, test the data list. Run it. 10. Okay. O value equals O value equals test data list. Zero split it by comma. And print O value 0. You can get something. No, it's no cover. Sometimes we should make sure what is 7, and we can image query array. Okay, image array we just we just copy and cut it, and let's make a more reasonable. Let's make it more convenient. O values data list. We just want to image this. Okay, we have got this, and only it should be 7. 1. O value 1, retrieve this one. Why? O value is already 7. Why this is image number O1 retrieve the wrong. Let me see what is value 1. Is it 7? Why is 7? Where? You didn't know the value where. 1. 7. We get a 7. Numpy array image array numpy value 1 retrieve as in programmer impute actual represent. And query. Okay, let's query. numpy is f(r)(ay), numpy for value for value 1 minus 1 0 times 0.9 plus 1. Let's see what happened. Whoa! 7. And this is 1. Why? Should we clear all these things? We started. I think we restarted. Name. You can get all this. Should be 7. There 1. Maybe we do not train. Why is 1? I just. It's a mistake. Okay. Okay, you can see the label for the series 7 and what will your answer when we queried. Indeed. One, two, zero, 1. I don't remember. What's this? What happened here? Image right. Always 1. 2. 3. No change. And then it's change. So this image we should let me track it directly. O value 1 reshape to image array lumpy SAF array O value 1 0 reshape. This is metaprotocol image array. Have grades interpretation and metaprotocol image is Wait a minute. Okay. Let's see. Okay. Actually, there's a little mistake here. Sorry for all these things. I know it still won't work. Now you can see why you should be careful. Why you should be careful. Okay. Should be careful when you coding. It's easy to recreate the following code and clap through it. Okay, we just copy test the neural network. We build a scorecard to recall the whole testing results. Test pass. Scorecard for we should do indent, print the copyright, input, output, labeled, print. If scorecard from the scorecard equals else scorecard equals. Okay, let's run it. 7 character, 7 networks, answer 2 character, 0 level. So what's the final? What's the final print scorecard? Print scorecard. 0. What's why? Why is 0? Is there something wrong? Append 1. I don't get it. Scorecard. Numpy accelerator output numpy max print the neighbor networks answer. Actually, I like to this one. I like this folder. Create neighbor. Let's see what's happening here. Go if 4. Okay. You have to include it in the. So it will. I think this time it works. Okay. So we got a scorecard. We have 1, 2, 3, 4, 5, 6 grade with 98%. So everything I think looks fine. I think looks fine. So make sure you know the intent. Intent is very important in the writing. Intent. This is the intention. Okay. Let's see. Okay, we got it. Everything is okay. So we can use the right now. We can use the calculate performance score. Zero 0.6. That's what we get. Then we use okay. Today we just talk about okay. Today let's stop here. I just talk about how to build a neural network with all the process, and I hope you get something. See you next time. Next time we will use the complete training set and test set to test the whole neural network. See you next time.